Thank you guys for having me. Thank you for being here. My name is Mel Ritchie. Like Will said, I am the lead technical consultant at Marigold Analytics. Marigold is a woman-owned firm of technical experts here in the DC area. Marigold does technical consulting both directly for government customers here in the national security space, but also with the Contractor Coalition, looking at curating bespoke technical solutions and assessing the fidelity of those solutions for a variety of analytic use cases and challenges. So that's what we do. We also have a couple commercial clients as well. Today, I'm going to be talking to you guys about graph analytics, which is probably one of my favorite analytic disciplines, things to go do. I think I also promised someone here that I would talk about entity resolution. Actually, they might kick me out if I don't talk about entity resolution. So to that end, we're going to be talking about entity resolved graphs. Before we get into entity resolved graphs and the implementation of such, I want to context set a little bit. And now many people in the audience are wondering why on earth KRR is on the screen in 2023, because this is a very old discipline. Knowledge representation and reasoning, how technical systems store, access, and retrieve data and information for some sort of reasoning, whether that is done by an analyst or an algorithm. So here, let me modernize that for you a little bit. We could just as easily be talking about data engineering and data architecture and data science. If you're in the commercial space, maybe you're talking about master data management or enterprise knowledge management and sense making. I know that's Senzing's word, sense making. Regardless of which synonym you use, and regardless of your discipline and domain, I contend that everyone here is working on the same basic challenge, which is how do we distill understanding and prediction from the vapors of the human experience and the data sets that our sensors collect within it. Whether we're using large language models or generative adversarial networks or simple statistics or we're building some routine application, we're all trying to do this aspect of reasoning and sense making, and that's where our focus is. That's great. Everyone wants to talk about the next analytic. Graph analytics, right? We think of that as a species of analytics. But what's actually more interesting to me are the gaps we have on the knowledge representation side of the house. So we are designing technical systems predicated on our understanding of how the most powerful system in the world does its job, right? The human brain. And we don't actually know how the human brain works. We have a lot of theories. Some of them are based in the neocortex. Some of them are based in the amygdala. Some of them are based in the hippocampus. But regardless, we have technical systems and architectures like deep learning architectures that are built on the basic functionality of the human brain, and we don't actually know what that is. So my point with all that is I think our exploration and the more interesting questions are in this knowledge representation domain. And I by no means mean to suggest that entity resolved graphs are, the answer to this, but I do think they fill a gap. Entity resolved graphs fill a gap in the knowledge representation domain because fundamentally the power of a graph is not so much, yes, graph analytics are super powerful, graph-based machine learning, but the power of a graph in your organizations is synthesizing data and making that synthesis available to analysts and to algorithms. That's where you really get the bang for the buck in graph space. So with that said, what I'm going to talk about today, I'm going to level set everyone just a little bit in graph space. So what entity resolved graphs are. And then I'm going to go through the 7 most common questions I get from customers when they're looking to implement a graph-based analytics solution in their organization. Figure maybe that could help everyone here. 7 top questions I get from pretty much everybody. And then we'll conclude with sort of my ideas around a technical architecture that helps bring this graph-based solution to fruition in an organization, which is the architecture I've been using for about the last 2 or 3 years across a variety of use cases. So that's what we'll do. I'll try to leave some time for questions. If not, I'll be around all day if you're not sick of listening to me talk after this. So the thing we love about graphs, to level set everyone in the room, graphs are the most human intuitive way to represent the world's data. Philosophically speaking, you are taking data and you are representing it in terms of entities or nodes and the inherent relationships between them. And entities can be anything. They can be people, companies, transactions, events, documents, you name it. The relationships between them can be any type of relationship. Phone call, personal relationship, banking transaction, impressions and conversions in the ad tech space. So the reason why graphs are so powerful from an analytic perspective is just being able to see all those data pre-connected and visually represented in front of you. And I talk a lot about graph-based representation. I use that word very purposefully because I think when lots of people think about graphs, they think about graph analytics and graph storage. These three terms on the bottom of the slide get conflated. So people think graph storage, graph visualization, graph analytics. Well, if you have a graph, you have all of those things. And that's not necessarily the case. You can render a graph visualization from not a graph data store, from a relational data store. You can have data visualized as a graph, but not really have any analytic functionality behind that. So this distinction gets really important when we talk about tools, and software of how to, put a graph in your organization. That's why I bring it up here at the beginning. Finally, for the level set, there are several use cases on the board. I'm not going to dive into any one specifically, but I'm hoping everyone in the room sort of sees themselves in one of the use cases up there, whether that's, a cybersecurity use case or the ad tech domain, customer 360, contact tracing and contagion. That was sort of a big one for the world in the last 5 years for sure. But these are some of the use cases that I've worked on in terms of implementing graphs at scale for organizations. So now that the level set's over, let's dive into the most common questions that I get. I don't know why I picked 7. 10 seemed like too many. I feel like we'd be here for too long. There were initially 12, so got down to 7. This is a great question. When is a bespoke graph database required? And by bespoke graph database, I mean like your Neo4j or your Tiger Graph. If I just said, which I just said, you can derive a graph visualization from a relational database, why do you need to pay for a separate database to host a graph? And the question really comes down to scale. So if you're dealing with greater than 1 million nodes or records, and you are driving your organization towards a graph analytic function, then you're going to require a bespoke graph database to handle that level of scale. Graph traversals are very computationally expensive. Graph-based machine learning algorithms, even more so. So this is a question I get asked a lot, and it's part of the discovery process going through with your organization. Like, what are you actually trying to do with a graph? Do you want a visualization or do you want an analytic capability? This is another big one. I find when people really understand the power of entity resolved knowledge graphs, immediately they're like, oh my gosh, this is great. Let me take all of my enterprise data, put it in a graph, and then everything will be connected and everyone will be happy. And ostensibly, yes, that is a great idea. Except I just got finished telling you that graphs don't scale particularly well. Now, if Neo and Tiger in the room, they will argue me to the death on that point. But the reality is they still don't scale super well. Graphs are most effective when you have domain-specific graphs. What I mean by domain-specific graphs is pick the collection of use cases that your analysts are going to want to go explore, whether that's in the financial transaction domain or the cybersecurity domain or the geolocational ad tech pattern of life style analytics, and build a graph around a cornerstone data source for that domain. These domain-specific knowledge graphs are what are going to lead to, your bigger analytic achievements, I'll say, because they're going to be focused on the questions your analysts are actually trying to answer. We've all heard that structure governs function from osteopathic medicine. Structure governs function. So the structure of your graph, your data model, your graph data store, and the domain that it is meant to represent is going to govern the analytic insights you're going to be able to get out of it. So long story short, no, a graph is probably not your enterprise data management solution. Okay, now I can get to the point where I talk about entity resolution. So how do data sets get connected in a graph? So say you're trying to bring two of your own data sources and one commercial data source into a graph-based environment for exploration. Two things are going to happen. One, you're going to bring in these 3 data sets, and you're going to have duplicates in those data sets, right? There's going to be 3 Mel Richies. The second thing that's going to happen is you're going to bring in 3 data sets that have connections within the data sets, but no connections among the data sets. So you're going to end up with 3 discrete little interconnected small worlds in your graph. To derive those connections between the data sets and among the data sets, and to deduplicate in the process, you need an entity resolution process that occurs at the data layer as you ingest the data. So entity resolution is your first step. Many people think it's like the last step, bring all the data in and then entity resolve it. It's actually when you're building a graph-based capability, entity resolution is your first step because it's your key to deriving relationships and connections within your data sets. And we'll see that in the architecture in a little bit. Offhanded question, but lots of my customers have unstructured data, PDF files or text. You can absolutely get those into a graph environment. You can have nodes that are documents. That's not very interesting, but sometimes it's useful for looking at the provenance of your data sources. But you need some sort of natural language processing pipeline to do the entity extraction, entity tagging, and entity extraction, and put those entities into your graph. It's a separate little pipeline you have to build, but yes, absolutely, graphs can handle unstructured data. This is something I find with a lot of customers where they have an analytic tool suite. They have an environment, whether that's an analytic environment, a federated search environment, what have you, that sort of combs through their data collections. And they say, well, we built a graph visualization on top of it. See, it's a graph. You can drag the nodes around and they spring back into place. And we got a little D3 JavaScript action going on and everybody's happy. And that looks very cute. But as I said at the beginning, graph visualization does not graph analytics make. So there's nothing you can get from that beyond seeing the connections in the data and like maybe, clicking on them. You don't get any of the benefits of graph analytics, like being able to run graph-based machine learning routines to do shortest path or nearest neighbors or clustering, things like that. The power of graph analytics is really in the fact that you get to use the inherent structure of the data as features on which to run prediction algorithms, which is a luxury you're not afforded if you're just dealing with, data in its raw form. So all to say that you can visualize data as a graph, and that's great. That might be all you need. But it does not lead to the greater analytic functions we're talking about in entity resolved graphs. When we talk about entity resolution in graphs, this is pretty important. I do want to make the distinction between graph-based entity resolution and entity resolution that occurs at the data layer, because many of my customers come and say, well, I heard so-and-so does their own entity resolution, or we're going to do graph-based entity resolution because it's better. Graph-based entity resolution is very powerful for the reason I just said. It uses structural features of the data to do its resolution, in addition to metadata and all the stuff that's natively germane to the data itself. But it does not scale. It's very hard. It's something you do after the fact. So the answer for graph-based entity resolution is yes and. You have to do entity resolution at the data layer first, as you bring all of the data into the graph environment, because that is the process that scales, and that is the process that connects your data in a way that an entity resolved graph is then rendered. Then, after the fact, if you'd like to have a couple data scientists go at the graph-based entity resolution problem, it will probably add to the quality of your entity resolution. It will discover more relationships in your data. It will be a value add, but it cannot be your only approach. It shouldn't be that definitive. It should not be your only approach to entity resolution across your entire architecture. And final question, question 7, what are the technology components required for a basic, graph-based solution? And that leads into my final slide. So I'm trying not to make anyone mad in the audience with this slide. This is by no means comprehensive. These are some of the bigger companies, bigger technology providers that we're all pretty familiar with. But the 3 primary components of the graph-based solutions that I've been building for the last several years are entity resolution, data storage, and visualization and analysis. So you have data sets coming in, and these can be structured, unstructured, internal holdings, proprietary collect, commercial data sets, classified, unclassified, kind of sky is the limit when it comes to the data sets, so long as relationships exist. Now, I would challenge you to find a data set where relationships don't exist, but as long as there are relationships to represent, then you're good from a graph perspective. You have to bring these in, as we discussed, through an entity resolution process. This answers the question, how do we connect these data? Now, there's no competitors next to Senzing, because I read somewhere the other day that people only advocate for things, like they only strongly advocate for things that are in question, and the things that everyone accepts as truth, they don't advocate for. So Senzing has no competitors because it's just ground truth. Jeff, that was for you. No, in all seriousness, if you are looking for an entity resolution solution that is a scalable developer library that gives you the explainability behind the resolutions, that gives you the ability to tweak your thresholds for what you want to consider a resolution or a connection, there is no other option. The other solutions for entity resolution are either baked into large platforms that you have to buy and adopt that entire platform within which entity resolution is a service, usually a more lightweight service than the type of sophisticated and robust entity resolution Senzing provides. Or you can grab an open source deduplication routine off GitHub and build your own microservice in a couple of days. But that is significantly less robust and comprehensive than what Senzing has been offering. So that is my chosen entity resolution solution for building out graph. When it comes to data storage, in the national security community, we use a lot of Neo4j. It has ATO in most places. By no means does not have to be the exclusive solution. AWS Neptune, Janus Graph, Tiger, MemGraph, all good options. And then we get to the visualization and analysis piece. And this is where, JavaScript isn't going to cut it. If you actually want a tool, and you need a tool that gives you that robust front end ability to iterate through your graph as an analyst, click through, query the tool, you're looking for something like one of the platforms up here. We've got Graphistry, Neo4j's internal solution, Gephi, Tom Sawyer, but I'm a big fan of a platform called Hume. It's made by a company called GraphAware, who may actually be wandering around here today. If you can find them, they would be glad to give you a demo of their tool. But it is designed for investigative workloads and case management. So it's a very analytically minded tool. And it's something that I've been using in my deployments for the past couple years. So I say that to you, by way of recommendation, but certainly, you can look at building your own tool. There are lots of tools out there. But the UI is really important because this is the place where your analysts are going to be able to interact with that deeply connected data. Graphistry, for example, they are doing wonderful, wonderful things for scalable graph-based machine learning, probably the best solution out there. In-memory, scalable graph-based machine learning workloads. Their visualizations are spectacular. They're not setting themselves up there, and by their own admonition, right? The CEO's like, this is not where we're going. They're not setting themselves up to be used for analytic workloads, for investigations. They are setting themselves up to be used by developers in the graph-based machine learning space to run these algorithms on massively scalable data sets. So just understanding which tool you're looking at and what your tool does is very important, and that should probably have been one of my 7 questions, helping people sort of demystify tools, what a tool actually does versus what it's claiming to do. That's something we do a lot of. So last thing, I think last point on graph. Graph is hard, right? I think everyone would agree. Graph is hard. It's its own thing. It doesn't scale well. It's not a problem for, really good software engineers. It's a problem for really good data engineers and data architects who have dealt with graph before, who know how to build out ontologies, who know how to build relevant data models for specific, like domain-specific graphs. This is a hard problem. It's not just, you feed all the data into Senzing and then it comes out and your graph is ready. There's quite a bit of architecting that goes into graph analytics. Red Horse is a company I've worked with before. They've done a lot of deployments. I have had the pleasure of meeting another company here during the course of the morning that does the same thing. Enterprise Knowledge. They're walking around here. So my only point with that is not to advocate for any one specific company or tool. It's just to make sure you're working with graph data engineers, because software engineers, like normal software engineers, like, we can just throw some good talent at this problem. It really requires more. It requires people who know how to architect graphs. And that's been a big lesson learned for several customers over the last few years, is just having the wrong people do the job. I hope you've seen the value of entity resolved graphs and where Senzing has fit into the tech stack that I've been deploying for the last couple of years. Thank you for your time.